This is ruler of the world. In this lab, we will be using a ruler to measure the length of different lines on a laminated sheet of paper. The first thing we need to determine in this lab is the resolution of our instrument, which is going to be this ruler. We're going to be using the metric side, and all of these numbers are going to be centimeters. Now, resolution is the smallest interval that can be measured by that instrument. So basically, if we're looking at this ruler, the resolution of this ruler is going to be the smallest line segments on this ruler. You can see that it's breaking the centimeters into 10 different parts. Now we also have to determine whether there's going to be an uncertainty digit. So an uncertainty digit means, are we able to estimate that next digit? So there are two different types of measuring instruments. We have analog and digital. Now this ruler is an analog instrument. So if we are measuring an object and that object falls in between those resolution, the smallest interval that can be measured, well, you can make an estimate to the next digit. That's important because what that does is we can record it and it increases our significant figures. So let's take a look at these 10 line segments. I'll do the first one for you. So I'm going to take that ruler, and it's transparent so it makes it easier to do. So I'm going to line up that 0 mark on the very edge of that line segment. Then I'm going to look and see where that line segment falls. So if we zoom in, you'll be able to see that that line segment falls on that first interval right after the 23. So it'd be 23.1 centimeters. But if we recorded it as just 23.1, that would be incorrect because of that uncertainty digit, right? So we have that resolution, but you can estimate. You know that if it falls exactly on that line, the next digit is going to be 0. So we can estimate that down to 23.10. That gives us 4 significant figures instead of 3. The purpose of this exercise is to practice recording what you can measure. Even if it's a 0, record that 0. So once you've measured all of these line segments, the next is to convert within the metric system. We should have recorded all of our measurements in centimeters. We're going to convert these measurements into meters, millimeters, and kilometers. I'll go ahead and put a metric conversion chart up there just to help us out. Now when you're converting, remember, if we can measure it, we still have to record it. All of your values, even when you're converting, should have the same number of significant figures. It does not change what we measure. It just changes how we represent it. The last thing we're going to do in this lab is we're going to take that transparent stick and we're going to put it on top of a wooden meter stick. So we're just going to compare. I've got 2 different measurements for length within the metric system. So what I'm going to do is I'm just going to line up that 0 mark on top of the 0 mark on this wooden stick and make sure all of those like little lines match up. So they should match up around like 1, 2, 3, 4, right? You can see that they fit really nicely on top of each other. But if you look all the way down to about 29 and 30 centimeters, you'll notice something. Now the lines are a little bit off. Now that's not going to have much of an error when we're measuring line segments, but it is important for us to have a distinction to say, hey, this is a centimeter, this is a meter. And that's what makes the metric system so great. This is just a representation of length within the metric system. This is just a representation of centimeters. Same thing, this is just a representation of meters. This is not the meter. This is not what we compare all other meters to. Everything in the metric system is based on a universal constant. Right now, the meter is based on how far light travels in a vacuum in a certain amount of time. And we base time on the cesium isotope, cesium-133. So if I were to do this lab, I might get 2 different measurements depending on what ruler I have, especially on those longer line segments. Now there is a way to figure out which one is more accurate. We just compare that with the meter, with that universal constant. So once again, this is ruler of the world.